The last type of nonlinear inequality we want to look at is a rational inequality, right? So we just studied rational functions, and so now we're going to study rational inequalities. And so the way to start this is I want to put this in our graphing calculator and just make some observations, right? Remember with polynomials, what we decided was that we only switch from being positive to negative when we cross a zero, okay? So is something like that true for rational inequalities? And so we're going to go ahead and graph this rational function. All right, so we'll type out here in the top. We got to be a little careful here. So put parentheses around everything on top. So I'm going to have parentheses, then parentheses x minus 2 times x plus 3, because I want both of those to be in the top of my fraction, divided by parentheses x times x minus 5. All right, so we'll graph that. All right, so here we go. Now, it's really easy to see from the function itself that we've got zeros at 2 and negative 3, and vertical asymptotes at 0 and 5. So clearly we switched from being positive to negative at between, before negative 3, after negative 3, it switches from positive to negative, okay? So it switched at a 0, like we were used to with the idea of polynomials. And it switched here at this other 0 at 2, right? Positive to negative. But notice that it made a switch from here to here. Okay, well, what's here? This is a vertical asymptote. So we can switch as we cross an asymptote as well. And same thing here. We were negative, and then we went across this asymptote at x equals 5. And now we're up here to positive. So that all just tells us that what we want to do now is not only find our zeros, but we also want to find what makes the denominator 0, or in other words, where the vertical asymptotes would be. All right, so let's go to that next page here. All right, so here's our steps for solving rational inequalities. Okay, just like last time, we're going to move all terms to one side. We're going to combine one side into a single fraction. Okay, you'll see how that works. Factor the numerator and denominator. Then number 4, determine the values that make each factor in the numerator and denominator 0, and list the intervals that these points divide the number line into. Okay, so it's just like the diagram that we used in the last, or with polynomial inequalities. It's just that now we're going to not only have zeros, we're going to have vertical asymptotes as well, essentially. Then we're going to plug in a test point, just like we did before, and then we're going to use that information to write the intervals that give us the desired result. All right, so let's look at example 8. We're going to start with a simpler one. And so essentially what we can say here as we look at example 8 is that numbers 1, 2, and 3 are already done for us. So let's just make a little note of that. Steps 1, 2, and 3 done already. Right? But now I need to figure out, okay, what makes the top 0? Well, x equals 0. What makes the bottom 0? X equals 1. Okay, so what we're going to do is we're going to make one of those charts. And I don't know if I used this term in the last video, but I'm going to make a sine chart is what we call it. But here's what I'm going to do. Remember last time I used solid lines when we were doing less than or equal to, and dotted lines when we were doing just less than or greater than, to remind me of when I'm going to use parentheses and brackets. So I want to do the same thing here, except every time I'm dealing with a vertical asymptote, I'm going to put a dashed line regardless of what this inequality looks like. So I'm going to put a dashed line on 1. But then I am going to put a solid line on 0 because it's okay to have x equals 0. That's okay, but it's not okay to let x be 1, right? Because that causes us to divide by 0. All right, and then from there, just like last time, we're going to plug in test points. So how about -1 for this one? So that's going to be -3 over +2. And again, the number doesn't matter. All that matters is that it's negative over here. All right, so in between here, how about 3 times 1/2 over 1 minus 1/2? So 3/2 over 1/2. And here's like, just stop here, right? All you need to know is that you have a positive divided by a positive, which is positive. And then 3 times 2, 1 minus 2. So we have 6 over -1, but it's negative. Okay, so what did we want? Well, we wanted negative to begin with, right? So we wanted this one, and we wanted this one. So here's our solution. -infinity up to 0. But this was solid, right? So I'm going to use a bracket on that. And then 1 up to infinity, but I see the dashed line. Reminds me, oh yeah, don't include 1. Use parentheses instead. All right, so now example 9 might look a lot like that previous one, but we definitely have something different going on, because while we do have just this single fraction involving x's like on the last problem, we have a 1 on the other side. And remember that our step number 1 was to move all terms to one side. And so I need, as my first step, to subtract 1 from both sides. So I have x minus 3 over 2x plus 5 minus 1 is greater than or equal to 0. Okay. And then step number 2, okay, so here's step number 1. Step number 2 was to combine everything on this side into a single fraction. So of course, anytime I want to combine into a single fraction, I've got to get a common denominator. So we got 2x plus 5 over 2x plus 5. It's greater than or equal to 0. Now I can combine them, but be very careful as you do this, right? I'm subtracting all of this. So I'm going to put parentheses around my 2x plus 5. All right, so x minus 3 minus 2x minus 5 over 2x plus 5 is greater than or equal to 0. Okay, so we're getting there now, but we need to simplify this over here. So I have a negative x, when I combine my x and my minus 2x, minus 8 all over 2x plus 5 is greater than or equal to 0. Okay, so now I've got it so the numerator and denominator are both factored. Okay, so that's really where I'm at in number 3, or with step 3 right here. All right, and now we're going to determine the values that make the top and bottom 0, right? So negative x minus 8. So we've got negative 8 equals x. And then 2x plus 5 is equal to 0. 2x equals negative 5, so x equals negative 5 halves. So we have the numbers negative 8 and negative 5 halves. Negative 8 makes the top 0, okay? And I have greater than or equal to, so it's okay if the top is 0, so I'm going to put a solid here to remind me to use brackets with that. But negative 5 halves would make the bottom 0, so regardless of this inequality, I'm using a dashed line with that. All right. Now I have plugged in values many times now, so you'll forgive me for maybe not going into all the detail here. But let's just say I plug in negative 9. If I plug in negative 9, this is going to show to be negative. If I plug in something between these, right, this is negative 8, this is negative 2.5. So how about if I plug in negative 4? That'll show that the expression is positive. And then if I plug in something to the right, like say 0, that'll show that the overall expression is negative. And so what do we want? We wanted the expression to be greater than or equal to 0, right? So that means we want plus in this case. Solid line means bracket. Dashed line means parentheses. All right. So example 10 would be a good opportunity to try this next one yourself. This one is a little tricky, but I would encourage you to try that one yourself. All right, so hopefully you paused and did that. Let's see if we get to the same thing. So remember, first things first, get everything on one side. So I'm going to move this one to the other side. So 1 over x minus 3, 1 over x plus 2, minus 2x over x squared plus x minus 2, greater than 0, right? But we've got to combine everything into one fraction. So that means I got to start looking for least common denominator. So I need to factor this fraction over here. And so if I factor this out, looks like x plus 2, x minus 1 will work. So there's some good news and bad news here. I mean, x plus 2 is a factor here, but x minus 1 isn't. So it looks like our LCD is x minus 3 times x plus 2 times x minus 1. So this thing is going to get a little ugly before it gets nice, all right? But I think we can handle it. So here's what's going to happen. We're going to take and this first one, let's just start with x minus 3, right? That's what it already had. But then we're going to multiply on top and bottom by x plus 2 times x minus 1 to give it what it needs. And then plus 1 over x plus 2. We'll multiply this one by x minus 3 and x minus 1 to give it what it needs. Minus 2x, and then the only thing it needs is x minus 3. Oops, let me do it in red though, like I was doing the others. So 2x over x plus 2 times x minus 1, and then we just need to give it x minus 3. And that's all greater than 0. Okay, so where does this leave us? Well, let's start multiplying things out. So x squared plus 2x, plus x, not plus 2x, as I'm foiling this out in my head, minus 2, plus x squared minus 4x plus 3, and then minus 2x squared plus 6x. Okay, so where does this, oh, and then of course all of that over x minus 3, x plus 2, x minus 1. Okay, so as you can see, I didn't plan my space too well. I run out of space here. But some good things do happen. Okay, so x squared, and minus 2x squared, that just all goes away. And then as I look at what I end up with, I end up with 3x, surviving as all the x terms, plus 1. Okay, all over x minus 3, x plus 2 times x minus 1 is greater than 0. All right, so now I just need to make my sine chart, and I'll be on my way here. So we have a 0, x equals negative 2, and 0 of x equals 1, 0 of x equals 3, and then this one, if you stick a 1/3 or negative 1/3 in there, that'll do the trick. So our chart looks like this: negative 2, negative 1/3, 1, and 3. Now, in this one, we would definitely use dashed for 3, for 1, for negative 2. But because the inequality itself is also just a strict inequality, I'm also going to use a dash for negative 1/3, even though it's in the numerator. And again, we've done this many times, so we're just plugging in a number that falls in each interval. So I'm not going to go through all the steps here, but this is what you should come out with. And what did we want? We wanted this expression to be greater than 0, right? So that means we're going to keep all 3 of those pluses. And because we have these dashed lines, we're going to use parentheses everywhere. So we'll negative infinity to negative 2. We'll keep negative 1/3 to 1. And we'll keep 3 up to infinity. All right, so like we did on the polynomial section, we can apply this whole idea here to finding the domain of a function. So if I wanted the domain of this, I could set this greater than or equal to 0, right? And then if this thing can factor 2x and x, so what would we have here? Looks like maybe +1 minus 3 will do the trick, right? Negative 3x plus 2x will give us minus x. Right, and so we could look at all these, right? 2x minus 3 equals 0. So 2x equals 3, x equals 3/2. X plus 1 equals 0, so x equals negative 1. X plus 5 equals 0, so x equals negative 5. All right, so making our sign chart here, we've got our negative 5, we got our negative 1, we've got our positive 3/2, and then we're going to be careful, right? Vertical asymptote gets the dashed. Negative 1 gets the solid, 3/2 gets the solid because those are zeros. And again, when we plug in values that are in each interval, here you'll end up with negative, positive, negative, positive, and we of course want to keep the positives. Right, we're keeping those. So this ends up being negative 5 to negative 1 with parentheses on the negative 5, brackets on the negative 1, and then join that up with bracket 3/2 up to infinity. All right, now the last problem here is just kind of an application problem. So it says that a solar panel manufacturer estimates that the profit in dollars generated by producing X solar panels per month is given by this equation. It says use a graphing calculator to help you determine for what range of values X is the company's profit greater than 12,000. Okay, so if S of X gives us profit, we want to know when is that greater than or equal to, or I guess just greater than, right? That's all they said, greater than 12,000, right? But of course, we have the formula for this, 8x plus 0.8x squared minus 0.002x cubed minus 4,000 is greater than 12,000. Now, if we follow the same rules we've been following, what they would say is go ahead and get one side equal to 0, and I think that's a good idea. So here we go. All right. Now, once we have that, understand that the way we can use a graphing calculator here is we can say, put that in as y1, and then see when is it bigger than 0, right? So let's go ahead and do that. So going in here and clearing this out, so we have 8x plus 0.8 x squared, and minus 0.002 x cubed, and then minus 16,000. Oops, I hate it when I do that. Minus 16,000. All right, so the graph here is, likely going to be not a very good view. So if I just hit graph, I'm not going to see much here. So one of the things we do need to do is be strategic about the values that we choose. So let's think about what's reasonable here. So if I go to my window, first of all, we're talking about the number of solar panels. That's the X value, okay? So let's, we don't need anything negative, that's for sure. And then, it's a little unclear, like how big of a company this is. Let's just go ahead and do 1,000. I can see what that kind of view that gives us. And then we do know that we're, they're talking about like $12,000 in profit and things like that. So the Y scale should be pretty substantial. And let's keep in mind, I'm trying to look for when am I above and below 0, right? So I'm gonna keep my Y values kind of like this. Let's do the following. Let's do like negative 5,000, okay, up to 20,000, just to kind of give us enough space underneath of 0 so that we can see things. All right, so here's our graph, okay? And so we can see when it is that the inequality that we had is greater than 0, which corresponds to when the profit is greater than 12,000 because of how we started it out. So just like we've already learned how to do, we can find these zeros. So second calc 0. And we just need to get to the left, and to the right, press enter. So it looks like 183. So on that end, 183 panels, but then you wouldn't want to make any more than what's on this other end. So let's see, here's the left, here's the right, so 344. So what we're saying here, going back to this, is that we should make between 183 and 344 panels. Now you might wonder, okay, what is, isn't it better just to sell more and more and more? Well, yeah, when the situation's really simple, but there can be all sorts of reasons why if you make too many, your profits maybe start to go down a little bit. So like maybe you only have the ability to get enough supplies to create a certain number of solar panels, and the only way to be able to go over a certain amount would be to start paying a lot more from them from a different supplier. So that would just be one example of how this might make some sense. But at any rate, we can use technology to help us here, but using these same principles of, okay, let's get everything on one side, the other side 0, and then find the zeros as we did earlier on with polynomials.